one final thing that I have to test, and that thing is moving the entire stack. If I can't move the entire stack, this machine is a complete
Welcome back everybody to the second part of my wood and concrete adjustable cable machine do-it-yourself video. In this video I'm going to show you how you can use standard pine lumber to build a very solid adjustable cable machine for around $200. If you compare this price to the rising prices of popular cable machines from popular name brand companies,
What? Bullshit!
you can see why a project like this is enticing for DIYers who also work out. While you could put any weight stack on this machine, like a vintage one from a vintage machine or even a new one from online, I'm going to be using my concrete weight stack that I built in a cave with a box of scraps.
Tony Stark was able to build this in a cave with a box of scraps!
I made a whole video on how to make this concrete weight stack, and I actually didn't know if it would ever work while I was building it, so putting it on this machine will serve as a good test for the validity of these concrete weight plates. To get the plates ready, I had to clear out all the holes, which there are 4 of per plate. Some concrete leaked in during the pour and obscured the inside of these holes. This didn't give me much trouble though, and was very easy with a long chisel and a hammer. The skills you will need to construct this machine are a basic woodworking ability, measuring, cutting, ripping, drilling, and sanding, and a moderate metalworking ability. You'll need to cut out metal parts with an angle grinder, drill holes, and weld a couple pieces together. My design utilizes standard lumber from the hardware store. The frame is made from 4x4s and can be constructed with 2 12-foot pieces. There are 2 pulley brackets, one at the bottom and one at the top. The pulley brackets are made from rip-cut 2x6s, creating a box around the pulleys. These pulleys can be bought cheap from Amazon and work great. They're 3.5-inch diameter, but you could use 4.5-inch pulleys as well. It doesn't really matter. Some components of the machine could not be made out of wood, so I utilized the cheapest form of steel tubing available, old plumbing pipe from a scrapyard. Don't worry, these pipes were all used for fire sprinkler lines. No poop material has flowed through them. You'll need 4 foot of 1 1/4 inch pipe, 8 foot of 1.5-inch pipe, and about 8 inches of 2-inch pipe. You'll also need about a 2 foot by 2 foot piece of at least 1/4 inch thick steel plate. All the metal needed for the design can be found at your local metal scrapyard for relatively cheap. You shouldn't be spending more than $50 on steel. I will be putting the price and material breakdown in the description, so check that for an exhaustive list of what you'll need and how much it cost me to buy it.
Wiz! Come here, Wiz. Wiz, come here.
Hi, Wiz! Good boy. Good boy.
I set up the miter saw to cut the length of all the lumber I need. If you don't have a miter saw, you can use anything really. A circular saw works well, or even a handsaw. This is all the lumber I need cut to length and laid out in the pattern of the cable machine. I took the 2x6s I cut to make the pulley brackets and rip cut the edges on the table saw. This squares the edges and gives the lumber a cleaner look. The side pieces of the pulley brackets' new width is 5 inches, and the top and bottom pieces' new width is 4 inches. I then gave all the lumber a quick sanding before connecting everything. It's just easier this way. The pulley placement along these pulley brackets is vital. Check my plans in the description for the exact measurements for where you need to drill these bolt holes that will hold the pulleys in place. For more accurate hole placement, I used the drill press and started with a smaller drill bit, then moving up to the correct size for the bolts that will hold the pulleys. Once the holes are drilled on either side, you can connect the lumber using the pulleys and bolts. I used oversized washers on each side of the lumber, meaning each bolt has 4 oversized washers on the outside but also on the inside of the wood. This is very important for the stability of the pulleys. The guide rods I will be using are chromed closet rods ordered online from Home Depot. You'll have to drill a couple holes that are slightly bigger than 1 inch in the 2 4x4s. Try not to use a hole saw for this because hole saws are fucking bullshit. The construction of the frame is very simple. Once I got the lumber in place and clamped down, I used these 6-inch Timberlock wood screws to connect the pieces. They have to be long to get through the 4x4s and have a good grip on the other piece. I was really worried about the wood splitting in the beginning, so I tried to drill as many pilot holes as possible. But eventually I realized the wood wasn't really splitting and I sort of gave up on that idea. With the frame constructed, I could continue building the pulley brackets. I put these 4.5-inch back pieces on first and made some pocket holes with the pocket hole jig. I then could sit the frame up on the pulley brackets and screw it into place. Next, I put the top and bottom pieces of lumber on these brackets, completing the box around the pulleys and concealing them inside. Obviously, the cable will be passing through these pulley brackets, so I drilled the appropriate holes on the top of the bottom bracket and on the bottom of the top bracket. These hole placements can be found in my design in the description. At this stage, the bulk of the woodworking is done, and I moved on to the metal stage of the build. There are a couple metal parts that I made in part 1 of this video, the selector shaft and the user interface. The selector shaft is a 6.5-inch pulley that screws into a 4-foot length of 1 1/4-inch plumbing pipe.
And it is heavy, as it should be. It's going to be a heavy stack, very powerful. Kind of like a fucking staff. The power of time!
While I did use the CNC plasma table to cut out these pulley brackets, you can easily cut out the parts with an angle grinder. This 1.5-inch plumbing pipe will serve as the third upright. The 8-inch section of 2-inch plumbing pipe will go around the 1.5-inch pipe and create a part that I like to call the user interface, because it's what the user interfaces with while using the machine.
Plumbing pipe, I'm going to weld it here like this. It is going to create a pivot point so that we can mount this bracket on a pin, which will be a bolt.
I will be mounting the 1.5-inch pipe between the 2 pulley brackets. While there are a couple different ways to achieve this, My strategy was to make 2 steel plates to mount to the brackets, then weld the pipe in place. The downside to this strategy is that I won't be able to remove the user interface ever again, but it is the strongest way to do it. Before I could weld the third upright, I drilled evenly spaced holes along the length of it. These holes correspond with one hole on the user interface and make it possible to mount the user interface at different heights, turning this cable machine into an adjustable cable machine. With the user interface in place and the steel plates attached with lag screws, I welded the third upright to the machine. The final thing to do with the metalwork is to drill the holes in the selector shaft. Since each concrete plate is 2 inches thick and the pinhole is in the center of each plate, the holes need to be drilled in 2-inch intervals. It was difficult to drill these holes precisely in the center of a pipe, but with a little care, it's definitely possible.
Fuck me.
Like I mentioned earlier, the guide rods I'll be using are these 1-inch diameter chrome closet rods that I ordered online from Home Depot. I'll try to put the link to these in the description, as they're pretty perfect and I highly recommend them to whoever decides to make this machine.
Come on, you bitch. You fucker.
The needed hardware for the guide rods is very cheap. You'll need 6 1-inch washers and 6 1-inch inner diameter shaft collars with set screws. I put these boards on the back of the pulley brackets in order to mount the machine to a stud in the wall. They also strengthen the pulley brackets. I recommend feeding the cable through the machine before putting on these stud mounting boards and the pieces that go on the front of the pulley brackets. The cable is definitely a little difficult to feed through the pulley brackets, but it could be fun if you invite your girlfriend over and tell her it's a fun puzzle.
No! I said no! Don't make me bop you with a stick.
You're performing surgery on my cable machine.
A bendier stick. Is there a bendier stick?
The screws I used to connect the bottom pulley bracket to the frame stick up about a 1/4 inch. Since the weight stack will be sitting here, I made this board to fit on top of the screw heads to create a flat surface for the weight stack to sit on. And it's oak and it looks kind of cool.
Where is the blue marker?
With mostly everything done, I gave the machine a good sanding and I rubbed it down with Danish oil. This gives it a great look and it doesn't look like it's made from the cheapest lumber available anymore. I mounted the double pulley bracket I made in part 1 on the user interface and swaged the bottom of the cable, which attaches on both ends to this user interface. I screwed the machine into a big stud in the barn. This made the machine extremely sturdy, and I only used one screw in the top and one in the bottom. The place I put it in was extremely not level, so I shimmed the right side of the machine and got it perfectly level. To put the weight plates on the machine, I moved the guide rods as far down as they could go and put each plate on one at a time from the top. Once the plates were on, I put the selector shaft in the middle hole and screwed its pulley bracket on. Then I could finally test if it even worked at all, which it did. I then swaged the other end of the cable after putting a golf ball with a hole drilled through the center of it to act as a stopper. It's DIY. And then it was done. Time to test it.
finished my wooden and concrete cable machine that hopefully everybody at home has the capabilities to construct. I'm finally ready to test it. I'm very excited. I've tested it a little bit. Other than that, it's a fresh test. Well, we'll check the sturdiness right now. I'll just try to jiggle it. And it jiggles a little bit. As you might know, I have these stud brackets on the back side, so I could screw it into a stud on the wall, and I just happen to have it in our barn. I would say it's 1% wobbly. So the lumber is good. It's a usable material for workout machines. All these metal parts, they're definitely going to be the hardest parts to construct about this cable machine. And I was really trying to not have any metal, but I just decided that it's impossible. It's impossible to not make this piece out of metal. Would be a lot more difficult to make it out of wood, and this piece, make it out of wood. This obviously could be wood. It might even be stronger if this is just a 4x4. I want to say that I didn't take a lot of your advice. I made a whole separate video about the concrete weight stack, and a lot of people thought that the weight stack was just going to crumble and get destroyed over use, and maybe over time, and maybe that will happen over time. But really, the only way that's going to get destroyed is if I were to just fucking drop the stack from like a height like this. It's not very difficult to gently set your weight stack down. I mean, just using this a little bit carefully is going to make it last, I feel like, forever. Like, this shit's not going to break. It's strong. I can set it down hard. And it's not going to break. Each plate has a rebar skeleton, and I mean, it would be very difficult to rip that entire rebar skeleton out of one of these plates. Now, it's adjustable, so you can take this out, and I'm going to move this thing up here, and as you can see, as I move it, the whole cable is going to be moving through the machine. And I'll move it to this position up here. This pin that I have right here is just a 1/2-inch bolt, and this pin I have right here is also just a longer 1/2-inch bolt. My pins aren't ideal, but you don't need anything more than 1/2 inch. By the way, I'm using one of these custom cable machine attachments that I created, which I think is fitting for this custom cable machine that I created. So this is a great exercise that you can do, and it's tricep extensions. And right now, I just have it pretty light. Let's see if I can go any heavier. So this is 8 plates, which should be 120 pounds. This should be heavy for a tricep extension. And it is! Fuck! I did it though, so that was half the stack. If you get the rope, switch attachments. Let me put it something pretty light here. And you can go ahead and do some face pulls and work your rear delts. And we'll go ahead and move it down. So you can see my pin is just kind of hard to get in there. Sometimes. And we can go ahead and try some lateral raises, standard cable machine exercise with just a single plate, just the top plate. And that's some good resistance. It's a little heavy. It's 15. It's probably closer to 20 pounds though, considering that this thing is has some weight to it. The selector shaft has some weight to it. But this is feeling great. My shoulders feel really good. Cable curls. Oh yeah. What other exercises do I love doing with the cable machine? I'll show you another one. This thing is heavy, and these are some weird flies to do. But you can do flies sort of like this. Do flies like that. What about some medium flies? Do medium flies work? They do indeed. So you can do some medium flies. It's sort of like a pec deck machine. You just gotta plant your body. Obviously, because you don't have another one. High flies work great, of course. And it feels great. Oh, yes. And that was just a couple of the exercises that you can do with an adjustable cable machine. And you can get your hands on one really easy with a lot of effort. You can create it, you can construct it yourself. And it feels good to build things. Okay, so there's just one last thing to do, one last test for my adjustable wooden and concrete cable machine where I created the weight stack, I created the selector shaft, I made the whole machine out of scratch. There's one final thing that I have to test, and that thing is moving the entire stack. If I can't move the entire stack, this machine is a complete failure. I made it with the whole stack. If it can't move the whole stack, what is the point? Jesus Christ and all gods that exist, please lift this weight for me and support my wood. Already not good. Oh! Support my wood! I'd say that was a success. That was successful. I did it. It moved. I believe in God now.